Hello everyone and welcome back to the sessions on quantitative methods for CFA Level 1. Now we are continuing with the topic testing of hypothesis, and as we have already started talking about the significance level from the past few classes, let us dive into the details of significance level from this class. Let us read something important about significance level. What is the significance level? The significance level denoted by alpha is the probability of rejecting the null hypothesis when it is actually true. So, you know what is that we are trying to do? We are trying to reject the null hypothesis, but there is a probability that the hypothesis may be true, but you are still rejecting. See, your evidence in hand is basically the outcome of the test result or the sample statistic. Through that you are trying to conclude, and the conclusion cannot be guaranteed to be correct. There is no assurance. That means there is a chance of error still. So, it is a probability that your conclusion may go wrong and you are going to reject the null hypothesis where actually it is going to be true. Let us read further. It determines how strong the evidence must be before rejecting the null hypothesis. It is a predetermined threshold for deciding whether to reject the null hypothesis. It reflects researchers' tolerance for making a type 1 error. Now, what could be a type 1 error? Now, this we haven't discussed earlier, but just for your understanding, let us understand what is type 1 error. This occurs when we reject a true null hypothesis. The significance level is the probability of committing this error. Example: in a medical trial, if alpha is 0.05 and we reject the null hypothesis that the drug has no effect, there is a 5% risk that we are wrong and the drug actually has no effect. So, we are rejecting the null hypothesis in favor of the alternate hypothesis, but where actually the drug had no effect. So, our rejection of the null hypothesis went wrong. Role of significance level in hypothesis testing. Now, first thing is with respect to the critical values. The significance level helps determine the critical values of the test statistic. The critical values defines the boundary for the rejection region. We have already seen this in earlier examples. When it is one-tailed test, if the test is one-tailed, the rejection region is on one side of the distribution. It could be either the left tail or the right tail. But if it is a two-tailed test, if the test is two-tailed, the rejection regions are on both sides of the distribution. The significance level sets the boundary for the rejection region in the test statistic distribution. It defines the critical value that separate the region while we reject the null hypothesis from the region we fail to reject it. The choice of alpha affects the type 1 error rate, that is the probability of rejecting the null hypothesis when it is true. Now, these are very important notes, and the real understanding of these notes you will develop when we are going deeper into the significance level, significance testing in the overall context of hypothesis testing. Alright then, when we observe the normal distribution, we notice that the critical values may lie on the right tail if it is a right tail test, critical values may lie on the left tail if it is a left tail test, and critical values may lie on both the tails if it is a two tail test. So, What is the meaning of significance level? When we are observing any calculation from the test statistic and it is somewhere coming near the mu, that is the mean, and may not be exactly the mean but somewhere near around that, that means it is not matching with the mean, going away from the mean, but if it is still near around, we will still not have enough evidence to reject the null hypothesis. Only when it falls in the extreme critical regions on either sides depending on one-tailed or two-tailed test, then we can reject the null hypothesis. So the point of understanding over here is, when you are rejecting a null hypothesis because the test statistic is falling into the critical region where the level of significance is defining a probability, that is a probability which indicates that you may still be wrong. This is what we call as type 1 error, where null hypothesis was actually true but you have rejected the null hypothesis based on your test result or based on your test statistic, because the values are falling in the critical region, that is in the significance zone, you are rejecting the null hypothesis. And that significance level, whatever percentage it may be, 1%, 5%, 10%, it is indicating a probability that you have rejected the null hypothesis when actually it was true. So that is where the whole process of testing of hypothesis may come across errors, and errors are classified into two categories: type 1 error and type 2 error. We are going to understand both the types of error in detail, but just as an introductory understanding, please try to follow one thing. When the null hypothesis is correct but we are rejecting it, it is type 1 error. Or when we are accepting the null hypothesis when we actually fail to reject the null hypothesis and we are wrong over there, it is type 2 error. So rejection of null hypothesis indicates type 1 error when actually the hypothesis was true. So let us identify the content ahead. Deciding the significance level. Now it is very important that you should be very particular about deciding the significance level. You should not go wrong over here. The choice of significance level should be made before conducting the test and should be based on the context, high stakes decisions and exploratory research. If it is a high stake decisions, lower alpha values, for example 0.01 means just 1% significance level, are used to minimize the risk of type 1 error in critical situations like medical trials. Now see what happens. When medical trials are conducted, the null hypothesis comes up with a statement that the new drug has no effect. Status quo, correct? That means the new drug has no effect. Alternate hypothesis would claim that the new drug has effect. Now, suppose you reject the null hypothesis and you accept the alternate hypothesis, which indicates that the drug has the effect, it has a significant effect. What may happen? You may start your proceedings ahead because you will believe that the research is successful because the drug has significant effect. Now, when you go ahead with your research and development project, you will start investing into capital assets and start spending huge amounts towards the development of the product. Imagine, what if your test result went wrong and you actually should have accepted the null hypothesis that the drug has no effect, but you rejected that in favor of the alternate hypothesis, where alternate hypothesis is claiming that the drug is effective and therefore you are continuing with your research and development, where huge amount, millions of dollars you are going to invest in your project. Maybe if it is a failure of your test or testing of hypothesis went wrong, it could be such a big blunder. We would want to avoid it. That is why when the decision is extremely critical, the decision itself is critical, where there is a high stake involved, the significance level should be very thin. That means very low significance level, very small scope you are giving for rejection of the null hypothesis. Because you are giving very small scope for rejection of null hypothesis, the probability of type 1 error also reduces. We would always want to minimize the type 1 error. However, all situations may not be that critical. For example, if you are going for exploratory research, higher alpha values might be acceptable in exploratory research where the cost of type 1 error is lower. Now, for example, it's a marketing research. You are carrying out a marketing campaign and you are carrying out a marketing research. For that research, you took samples of some people's opinion about what kind of product they are actually liking. Maybe your sampling has an error and that error leads to error in your hypothesis testing. Type 1 error only. But what happens? You are not investing a huge amount in a project. It's not a big capital expenditure that you are incurring. Maybe your advertising campaign and your effort for taking a marketing research, it went wrong. But you may carry out another round of research, exploratory research or marketing kind of research. Even if the test goes wrong, it is not a big stake involved. Therefore, over there, if you keep very thin value for rejection of null hypothesis, most of the times your null hypothesis you will fail to reject, and what you could have done in your marketing approach, you fail to do that. Therefore, you should always look into how much risk you can take, and accordingly you set the level of significance. Higher the level of significance, higher is the risk involved. Lower the level of significance, lower is the risk involved. That's the outcome of this entire discussion. Now we come across the next thing, that is p-value and significance level. I haven't explained you what are p-values, but just for initial introduction, I would say the p-value is the probability of obtaining a test statistic at least as extreme as one observed, given that the null hypothesis is true. If the p-value is less than or equal to alpha, we reject the null hypothesis. If p-value is greater than alpha, we fail to reject the null hypothesis. Now, this entire application, I am not going into the details of this. It is only at a little later stage when you will actually understand the role of p-value. As of now, let us just consider this for notes writing purpose only. Moving forward, suppose you perform a hypothesis test with alpha equal to 0.05 and you obtain a p-value of 0.03. Since 0.03 is less than 0.05, you reject the null hypothesis. If p-value were 0.07, you would not reject the null hypothesis, because 0.07 you would found that it is greater than 0.05. So moving forward, impact on significance level, that is alpha. For a one-tail test, the entire alpha is allocated to one tail, making it easier to reject the null hypothesis if the test statistic fall in the rejection region. Two-tail test, alpha is split between the two tails, making it harder to reject the null hypothesis since the rejection region is divided. Now we have seen the impact of this in two-tail test already. In examples ahead, we will continue to observe lots of examples for one-tailed and two-tailed test, and I'll show you why in case of a two-tailed test things become difficult for the rejection of null hypothesis. Significance level, that is alpha in one-tailed and two-tailed test. Let's discuss how significance level alpha is applied. In a one-tailed test, the entire significance level, that is alpha, is placed in one tail where you are testing. For example, if alpha equals to 0.05, the critical value that corresponds to the upper right or lower left, that is 5% of the distribution. Upper right or lower left means if it is depending on whether the test is a right tail test or a left tail test. In a two tail test, the significance level alpha is split between the two tails. For example, if alpha equals to 0.05, then each tail has 2.5% of the distribution, that is 0.025 in the lower tail and the same in the upper tail. So you have already observed one thing, that if it is 5% significance level in a two-tailed test, the significance region or the significance level gets divided into two tails, and the entire big region, if your test statistic fall in this region, you fail to reject the null hypothesis. As a result, only when it is going to the extreme values, then and then only your hypothesis, that is null hypothesis, will get rejected. What we are trying to say, suppose it is a one tail test with 5% significance level, and say it is a right tail test, then 5% will fall on the right side of the graph, correct, on the right side. If 5% is falling over there, you have the rejection region which is 5%. But if it is a two-tailed test with 5% significance level, only 2.5% is falling on the right and another 2.5% falling on the left. It becomes little difficult to reject the null hypothesis, because the possibilities that you fail to reject the null hypothesis becomes bigger. That is where your acceptance of null hypothesis becomes more frequent when it is a two-tailed test, because you have a lesser chance to reject the null hypothesis. Though either way, if the level of significance is 5%, your acceptable region is going to be 95%. In one-tailed test, what happens? One side there is rejection region, one side there is acceptable region. But in the two-tailed test, both the extreme left and right tail will have rejection regions, and only in the middle section you will be finding the acceptable region, or a region where you fail to reject the null hypothesis. So let's do one thing. We will be writing some important notes in this regard now.